Hello everyone, I hope you're doing well. So in this video, we're going to discuss the solutions to the problems of Codeforces Round 871, which was written for Division 4. So I was able to solve all the problems except the G1 during the contest. So we are not going to discuss the G problem for now, and we'll be discussing all the other problems. And I believe like G problem is also not very difficult. I just didn't get much time to implement it. That's why you see I made a wrong submission and I didn't have much time to correct it. So, like I believe like today's problem set was very good. I really enjoyed the problem set according to a diff 4 round, and I wasted a majority of my time in problem D and problem F. So I was not able to figure out some test cases in problem F. I was getting wrong answer, and in problem D, it took me some time to think of the logic. So the I believe like overall the problem set was very good for a division 4 round. Now let us quickly start with the problem discussion. So this video can be a bit long. You can skip to the question parts. I'll mark them all as chapters. You can skip to the question you want to listen to. And let us quickly start with the problem first. So the first problem is love story. Now this problem is very straightforward. It says that we have been given a string S of exactly length 10. Now we have to tell the number of characters which differ from the string code forces, right? So if I'm taking the first character of C, I have to consider the first character from here, right? If they are different, I have to add 1 to my answer. So like this is very straightforward. I don't think that there is a need for the discussion, but still I'll still show you the code how it can be implemented. So you see I've taken an input string S and I've taken the string T as code forces. So what I have to do is I just have to run a simple for loop. So this is a for loop. I've defined it as loop, right? So I'm running a simple for loop starting from 0 till less than 10, and I'm adding 1 to my answer if S of I is not equal to T of I, right? So this would be the solution of this problem, and at the end I can just print the value of answer. So let us move on to the second problem, which is blank space. So this particular problem is also very straightforward, and this is a technique that you would use in other problems as a very small part of other problems. So basically we have to tell the longest substring or the longest consecutive elements which is containing only 0. For example, if you see the last test case, the longest consecutive elements is 3 because 0 is coming 3 times consecutively. If let me just write it down for you. So let's say we have some zeros, and then we have some other character, and then we have some zeros. So we have to find the length of this longest substring or the length of the longest subarray such that it only consists of 0, right? So there are multiple ways to say this. You can also say them as they are the length of longest consecutive zeros. So this is 3 plus 3. So this is 6, right? In this case the answer is 6. So this is what we have to compute. Now there is a very standard way of solving this particular part, and you will also find it like as a small part of many other problems. So what I've done is I've taken an integer n and I've created a vector of size n and I've taken input array. Now I've initialized my answer with 0 and my current with 0. So current is actually denoting the current size, right? I'm running a loop starting from 0 to less than n, and if v of I, this means if v of I is not equal to 0, I'll set my answer as maximum of answer comma current, and I'll set my current as 0. So current is actually denoting the current size of the consecutive zeros. So since I've encountered a non-zero element, I'll set my answer as maximum of answer comma current, and I'll set my current as 0, and I continue. And if this is not true and this continuous statement is not executed, that means my current element is 0, so I can increment the value of current, right? So this way I'll always have my answer the maximum length of consecutive zeros in my answer variable. Now it might happen a case that the number of zeros were at the end. So for example, in this particular case, like this, now my answer variable, if this is the case, my answer variable after traversing the whole string will still be 0, and my current variable will be equals to 4 because I never got the chance to update my answer variable. So right, I'm just telling you this so that if you are new to solving problems, you remember this thing. So like when you traverse this whole string once, your answer will not be updated because we are updating the answer only when the current element is a non-zero element, right? So in this case, you see there is no non-zero element after this particular element. So at the end of after traversing the whole vector, my answer value will be 0 and my current value will be 4. So at the end, after traversing the whole vector or array, I again have to update the answer once so I can take the maximum of answer comma current. So I didn't update it like this. I just directly printed the maximum of answer comma current, right? So this would be the solution to the second problem. Now let us move on to the third problem. So this third problem says is Mr. Perfectly Fine So basically, it says that there are some books, right? And each book can give you either 0 skill, either 1 skill or 2 skills, right? So this is, so the first character represents skill 1 and the second character represents skill 2, right? So this is what they are saying. Now, what you can do is, you have to tell what is the minimum time. So there is some time associated with reading the books. We have to tell the minimum time such that this particular person, Victor, can acquire both of the two skills. So let me just discuss it. And there is a very neat trick to solve this, for solving this question. So for example, there are some books which gives you 0 skills. So obviously there is no use of reading such books. We are just definitely going to discard these kind of books. Now there will be some books that are giving you skill 1 and there will be some books that are only giving you skill 2, right? And there will be some time associated with it. And also there will be some big books that are giving you both skill 1 and skill 2, right? So among all the books that are giving you skill 1, you can find the minimum time T1. Among all the books that are giving you skill 2, you can find the minimum time T2. And among all the books that are giving you both of the skills, you can find the minimum time T3, right? And at the end, what you will do is T1 plus T2 comma T3. You will take the minimum of these two values. So the first value will be T1 plus T2 and the second value will be T3. Right. So this is a very straightforward way of solving this problem. If you combine these two times, you will get one from here and one from here. So you will acquire both of the skills. Right. And if you read T3, a book with time T3, you will acquire both of the skills from a single book. Right. So this would be the way of solving this question, where this would be the most straightforward way. So let me just show you the code, what I have done in the code. So you see, I've taken an integer n and I've initialized ABC with infinity, right? So I'm just traversing through all the n values and I take the time t and string s as input, right? So if the string s is equals to 1 0, that means I can get skill 1 from this particular book. I set a as minimum of a comma t, right? Else if s is equals to 0 1, that means I can get the skill second skill from this particular book. So I set b as minimum of b comma t. Now if the value of s is equals to 1 1, that means I can acquire both of the skills from this particular book. I can set the value of c as minimum of c comma t, right? So at the end I can set my answer as minimum of a plus b comma c. But what if the answer is still equals to infinity? That means there is no way that in which you can read the books so that you acquire both of the skills, right? So if the answer is still infinity, I would print -1, otherwise I would print the answer value, right? So this would be the solution for the third problem. Now coming on to the fourth problem. So this problem was very interesting, and it says that we have been given a single pile of n gold nuggets, right? So basically you have n, you can say it anything, you have n items, let's say, right? Now what you can do is, if you have a pile of n items, you can divide that particular pile into two piles such that one of the piles is exactly twice as the other pile. So for example, if you have the pile with value 6, like there are 6 items in this particular pile, you can divide it into two piles such that one of the piles, here it is 4, is exactly twice as the other pile, right? And the sum, obviously the sum should be equal to the original pile. So 2 plus 4 is equal to 6 and 4 is twice of 2, right? So this is our question. Now they are asking us whether if you have been given the value of n and m, we want to know whether we can form a pile of exactly m items or not, right? For example, if the value of n was 6 and the value of m was 4, right? So I can divide 6 into two parts, 2 and 4, such that I can form a pile with 4 items, right? So this is what they are asking. Now this problem has a very interesting solution. Like the way I solved it, I found it very interesting. So you see, like for example, if I consider some numbers, so using 1 and 2, you can form 3. Using 2 and 4, you can form 6. Using 4 and 8, so what I'm doing is I'm taking a number and taking its double. So I'm taking another number and taking its double, right? So also using 3 and 6, you can form 9. Using 4 and 8, you can form 12. Using 5 and 10, using 5 and 10, you can form 15. And using 6 and 12, you can form 18. So you see all the numbers that we are trying to form. If we take a number x and we take 2x, so we are trying to consider all the values of x starting from 1, 2, 3, 4, 5, 6, we have considered 6 values till now, and we see whenever we add x plus 2x, it is always a multiple of 3. Why? Because x plus 2x is 3x, so it will always, so it is always going to be a multiple of 3, right? So we will have our values like this: 3, 6, 9, 12, 15 and 18, right? So whenever we add a value x to its twice, that is 2x, we will always get a multiple of 3, right? So this is our first observation. Now that means if I have a number m and I want to divide it into two numbers x and 2x such that the total sum is equals to m, right? So I can easily find the value of x by doing m by 3, and I can find the value of 2x by doing 2m by 3, right? So these will be the two values that I can form by dividing m into two parts, right? So let me just write it more clearly. So m is here, I can form m by 3 from it, and at the same time I will be able to form 2m by 3. Now I have the choice to divide this particular m by 3, or I can also divide this particular 2m by 3. So let's say I divide this m by 3 further. So this will be equals to m by 9, and this will be equals to 2m by 9. If I divide this particular thing further, this will be equals to 2m by 9, and this will be equals to 4m by 9. I still want to divide this further, let's say. So this will be equals to m by 27, and this will be equals to 2m by 27. Similarly, I'll get 2m by 27, and I'll get 4m by 27. Again, I will get 2m by 27, and here I'll get 4m by 27, and this is 4m by 27, and the last one is 8m by 27. So you see, if I'm if I keep on increasing this tree further, I'll get some values m by 3 raised to the power I, and for each of those values I'll get 2 raised to the power 0, then I'll get m by 3 raised to the power I, 2 raised to the power 1, then I'll get m by 2 raised to the power 2, 3 raised to the power I, and then I'll get m by 2 raised to the power I and 3 raised to the power I. So these are the values that I'm getting. So you see, initially the value of 3 for I in this level, I is equals to 1, right? So I am getting m into 2 raised to the power 0 by 3 and m into 2 raised to the power 1 by 3, right? These are the two values that I am getting here. At this particular level, the value of I is 3, I is 2, since 3 square is 9. So I am getting m by 9, I am getting 2m by 9, and I am getting 4m by 9, right? So this is m by 9, this is 2m by 9, this is 4m by 9. In the next level, the value of I becomes 3. So this is m by 27, I am getting 2m by 27, I am getting 4m by 27, and I am getting 8m by 27. So this is m by 27, this is 4m by 27, this is 8m by 27, and this is 2m by 27, right? So you see, for all levels, whenever I have some value I am getting m by 3i and up to 2 raised to power m into 2 raised to power I by 3 raised to power I, right? So our general observation would be, so now since I know that I am getting all these values for any value of I can just brute force through all the values of I. So what I'll do is till I am able to form m by 3i, after a certain point you will realize that trying to form m by 3i is not possible, right? After a certain point it will not be possible. So till it is possible, I'll try to form m by 3i, right? Once I am able to form m by 3i, so for all values of j starting from 0 to I'll try to find m by 3i into 2 raised to power j, right? If this particular value is equals to the value I want, that means I can form my answer, otherwise I cannot form my answer, right? So this will be the solution for this particular problem. Now let me just show you the code. So what I've done is, so you see, I've taken a loop from 0 to 15. So the values of, I believe n was up to 10 to the power 7 or 6. So let me just check it quickly. So it is 10 to the power 7, right? So I just checked whether 3 to the power 15 was greater than or equals to 10 to the power 7 or not. So this is the lower bound that I could take. So that is why I have taken 15 here. So what I do is I initialize the current value x as 3 raised to power I. So this is my modular exponentiation function. It is calculating 3 raised to power I. And I have initialized y with 1. So this is essentially 2 raised to power 0. So if n mod x, that means if I am dividing n by x and it leaves a remainder, that means n divided by 3 raised to power I leaves a remainder and it is not directly divisible, that I can just break, because I have already told that after a certain point it would not be possible to divide n by 3 raised to power I. Otherwise, what I'll do is, if it is possible, then for all the values from 0 to I, so this is including I, 0, then I. What I do is, if I check whether n by x, that is n by 3 raised to power I into 2 raised to power j. So y is 2 raised to power j is equals to m, then I can print yes, otherwise, I can just return from it. Otherwise, what I'll do is, I'll multiply y by 2. So what I'm doing is, initially y is equals to 2 raised to power 0, then it will be equals to 2 raised to power 1, then it will be equals to 2 raised to power 2. Right, so that is why I'm multiplying pi by 2 at each step. So like if I am able to form the answer in any of those cases, I'll just directly return from it. Otherwise, if I'm not able to form the answer at the end, I can just print no. So this will be the solution for the fourth problem. Now this is this particular problem, that is lakes. This is a standard graph problem, and you just have to do grid DFS. There's there's nothing much about discussing on this particular problem. If you know DFS, if you know grid DFS, you will be able to solve this particular problem. So let us just quickly discuss what this problem says. We are going to discuss one particular sample test case. So for this particular sample test case, I believe the answer is 16. Now let us try to find how it can be 16. So they say that all the non-zero values, that the values that are greater than 0 are denoting a lake. And let's say 0 is land and all the other values are lake. So if it is a non-zero value, the value that is present, so for example at this particular index 1 is present, that means the volume of that particular water cell is 1. And if a lake is connected, that means if I'm able to go from one point to other, this is considered as one water body. This is considered as one whole water body, right? If there is a 0 in between, I cannot traverse from here to here, then this will be considered as two separate water bodies, right? So I have to tell the maximum volume among all the water bodies, right? This is a question. So this is a very straightforward question of connected components, and you can find the maximum value in each of the connected components. So let me just show you the code for this particular problem directly, because I feel that there is no point discussing in this particular problem. It's just a simple implementation problem of connected components. So what I've done is, let me just show you. I've taken n and m as input and I've created a grid vector, right? So this will be of size n cross m. Now I've run a for loop for I is 0 to less than n and j is 0 to less than m, right? So I'm taking input in that particular grid. Now create my visited vector and mark all of them as false. And I initialize my answer with 0 and current value with 0. So this is what I'm doing. So I'm checking for all the values, for all the cells. If the current cell is valid, I'm initializing the current value with 0. I'm initializing DFS with the current cell, and I'm marking answer as maximum of answer comma current. So these are the three things I'm doing. So first of all, let me just discuss this valid function, right? What is this valid function? So in valid function, what I'm doing is I'm taking two values x and y. So this is the first condition to check whether the current cell is out of bounds or not, right? So if x is less than 0, if x is greater than equals to n, and y is less than 0 or y is greater than equals to m, it will be out of bounds for my grid in zero based indexing, right? So if one of those condition is true, I am going to return false. And if the current cell is already visited of xy is true, I will return false. If the grid of xy is equals to 0, again I will return false. So these are the three conditions in which I am going to return false, which will denote that my current cell x comma y is not a valid cell to enter, right? Otherwise I will return 1. So once I know that this is a valid cell, what I'll do is I'll initialize my current value with 0 and I'll start my DFS from I comma j, right? And after the DFS is completed, I'll mark my answer as maximum of answer comma current. So let us see what is inside the DFS function. Inside the DFS function, I am marking the current cell as visited, right? So once I have entered that cell, I am marking it as visited. Now I'm updating my current answer as current plus is equals to grid of xy, that is the value or the total volume of the current cell, right? Now I'm trying to traverse in all the four directions. So I'm checking the first direction as x plus dx of I, and the y coordinate will be y plus dy of I, and I check whether the current this particular index xx and yy as a valid index, then I'll just continue my DFS at that particular index. Now, if you are wondering what is this dx and dy array, so I have initialized them here, and these are just normal arrays. These makes grid DFS or grid BFS very concise. If you use this function, you will be like at very ease, because I've also marked a comment. So this particular -1 and 0 indicates upper direction. So what I'm doing is, if I just add dx of 0 to my x variable and dx of dy of 0 to my y variable, I'll move one step upwards in the grid, right? So this is what this particular dx and dy array is denoting. If you have not used it earlier, I highly recommend to use this particular method of traversing in a grid, and this method is very useful. It helps you to write very concise code, right? So this is what I'm doing in the dx and dy function, dy array. So after all the DFS is done, after I've like find out all the possible ways, I can just print my answer. So this would be the solution of this particular problem. So again, this problem was a very standard problem, and I would say this, you can also say that this is a repeated problem because this is used in many other places as well. So let us discuss the next problem, forever winter. Now, like according to me, this problem had more submissions than I expected. So it had around 4,000 submissions. But still, like, this problem was not difficult. I was just missing a few test cases. I'll also explain what test cases were those which I was missing initially. So, but the observation of this problem was not very difficult. So let us quickly discuss this particular problem, forever winter. So it says that there are some values x and y. So initially you will have a central cell, right? You will have an initial node. So you have to connect x number of nodes to it. So if the value of x is 5 and this is the initial node, you have to connect 5 nodes to it. So let me just show you with the help of some illustration. Let me just take it here. So this problem says that if the value of x and y is 5 and 3, x is equals to 5 and y is equals to 3, right? So if x is equals to 5, you will have one initial node at the center, right? So this is the initial node. Let me just write it as initial node. Now this particular node has 5 other nodes connected to it. So this is the first node, this is the second node, this is the third node, this is the fourth node, and this is the fifth node, right? Now these 5 nodes have y number of nodes connected to it. So each of the 5 nodes will have y nodes. So this is the first node, this is the second node, and this is the third node. And you will see all these kind of nodes will have 3 nodes connected to it, right? So there will be basically 2 levels of nodes. So this is the first level, this is the first level, this is the second level. These nodes are at the second level. Now we have been given a graph initially. We have been given the edges. We have to tell some values of x and y, right, such that it is valid for the given graph. Now they say that the graph that they are giving will have valid values of x greater than 1 and y greater than 1, right? So they are mentioning this in the question. They've mentioned it somewhere here that it is guaranteed that this graph is a snowflake graph for some integers x and y both are greater than 1, right? So this is something they are mentioning. Now you will see that all the nodes that are at the outermost level or the third level have only one edge connected to it, right? So this way, the first observation would be to count the number of nodes which have only one edge connected to it, right? So in this case, the number of nodes will be 15, right? By this particular method, I'll be able to know that the number of nodes that are in the outermost level. Now the number of nodes that are in the middle level will always be a factor of this particular number. Why? Because only then I'll be able to do 5 into 3 and I'll be able to calculate the number of outer nodes. So I know for sure that it is going to be a factor of this particular number of nodes in the outermost level. So since I cannot take the values 1, I'll only consider the values from, or I'll only consider the nodes from 2 till less than n. So if this is n, the number of outermost nodes, I'll only consider all the values between 2 and less than n, right? So once I know now I can just brute force through all the values, since the number of nodes, the total number of nodes are only up to 100. I can also brute force for all the factors, and I can brute force for all the values and try to find whichever of them is working. So there is one more very important thing. You will be able to find all the factors of the value n. Now how do we check whether this particular factor is a valid configuration or not? So you see, if you have this particular, the number of outermost nodes is 15. Now you are checking for a value 5. So checking for value 5 means you are assuming that there are 5 nodes in the middle level. So in this particular level, you are assuming that there are 5 nodes. How do we actually confirm that there are exactly 5 nodes? So you will observe that there will be exactly one node, that is the central node, that will have the degree equals to 5. Right? There will be exactly one node that will have the degree exactly equals to 5, and there will be exactly 5 nodes that will have the degree equals to 15 by 5 plus 1. So how am I getting this particular value? So since I have assumed that 5 are the number of nodes in the middle level, that means for each of those nodes at the middle level, the number of nodes in the outermost level is 15 divided by 5. So you see, if I am assuming 5 to be the answer, that means 5 nodes are in the middle level. That means 15 by 5, that is 3. 3 will be the nodes in the outermost level for each node. So each middle level node like this is connected to 3 nodes in the outermost level and 1 node in the innermost level. Right? So the total number of nodes it is connected to, or the total number of edges for it, will be 4. Right? So this is 15 by 5 plus 1. So what I am saying is, if you have a value n, right? So this is the number of nodes in the outermost level. So first of all, we traverse through all the factors of n. Now let's say one factor is I. Right? So we want to test whether an answer for I is possible or not. So we are testing for I. That means we are assuming that there are I number of nodes in the middle level. So if there are I number of nodes in the middle level, there should be exactly one node with the number of edges equals to I, and there should be exactly I nodes with the number of edges connected to it equals to n by I plus 1. Right? So this is our condition. If this condition is satisfied, then our answer is possible for the corresponding values of I and n by I. Right? So this would be our answer in that case. So I missed one particular case, very important case, when this becomes equal. So I is equals to n by I plus 1. So let me just illustrate the case to you. So the case would be something like this. So here the number of outer nodes is 6, right? So we were trying to traverse through the factors of 6. One factor is 2, other factor is 3. So let's say we assume that the number of elements in the middle range is 3, or then the middle level is 3. So if the number of nodes in the middle level is 3, we are assuming this. That means there should be exactly one node with the frequency 3, right? And there should be exactly 3 nodes with the frequency 3, right? So if we see that these two values are equal, and the number of nodes with the frequency, or the number of nodes which have the edges connected to it, are equals to 3, then their frequency will be 4, right? So this is 3 comes from here and 1 comes from here. So this case was giving me wrong answer during the contest, and I had to consider it separately, that whenever these two values are equal, right? So I can just check their combined frequency. Otherwise, I can also check their independent frequencies. So let me just show you the code now, what I've done in the problem. So what I've done is I've taken two integers n and m, and I'm taking a vector called in degree. So I'm storing so in this particular vector I'll be storing the number of edges connected to one particular node. So I'm taking x and y as input, and I'm decrementing both x and y for zero based indexing. I'm incrementing both of them by 1, right? So I've initialized my count with 0. So I just traverse through all the values, and in the in degree vector, and when I check, whenever the value is equals to 1, I increment my count. So incrementing my count means that I am storing the number of nodes that are present in the outermost level. So I calculate its factors, and so this is just simple factor calculating, and it is not even complex. Since the value of count was very small, I directly just iterated through all the values, right? So if the current element I divides count, I can just push it into my factors vector. So I'm traversing through all the factors. I've initialized C1 and C2, so this will be the frequency, and this will be the first element that I need, and this is the second element that I need. So now I'm traversing through the index vector. So if j is equals to the first element I need, I increment the frequency C1. If j is equals to the second element that I need, I increment the frequency C2. So this is the first case when when need 1 and need 2 are different, right? So in that particular case, C1 should be exactly equals to 1 and C2 should be exactly equals to I. If this is true, I print I and count by I as my answer, and I just return from here. Otherwise, I check if need 1 is equals to need 2, then both of the frequencies combined should be equals to C1. As I have discussed in this case, like 3 plus 1 was stored in one single variable 4, and both of the values were 3. So I just checked if C1 is equals to I plus 1 or not, right? So I directly check it here, and if it is true, then I print I and count by I as my answer. So this was the case that I was missing earlier, and I was getting wrong answer because of it. So let me just discuss the last problem for today. So this problem was a very interesting DP problem. This was not very difficult, but yes, you would enjoy solving this particular problem. So this particular problem says that we have been given two values n and k, and we will be given an array of size n. Right, now we have to count the number of subsequences in that particular array, such that if we take the bitwise AND of all the values, then in the final value the number of set bits are exactly equals to k. Right, so this is what we need. But you will observe that the constraints on this particular problem are very small, and the value of ai is only up to 63. So if the value is ai is only up to 63, we can only have up to 6 set bits, right? So these are the constraints of this particular problem. Now let us discuss how we can solve this problem with dp. So I'll form my dp state sets, dp of I comma j, where I will be denoting the current index. I will be denoting the current index in the input array, and j will be denoting the current mask. So basically j will be denoting the bitwise AND of all the values that I have taken till now. So it can be a value starting from 0 till up to 63, right? So it's basically the bitwise AND of all the values I have taken till now, right? So initially what I'll do is, for each value of I, or for each index, for each element, I can decide whether I want to take the current value or not, right? It's up to me whether I want to take the current value or not. So if I decide to take the current value, then dp of ij, if I decide to take the current value, then dp of ij will be equals to dp of I minus 1 and j and v of I, right? This is the case when I decide to take the current value. What is happening here? I minus 1 means I am making the transition to the previous element, right? So if I have considered the current element, now I move on to the next element, and this is the mask that I am changing. So the current mask was j, and since I have to take the bitwise AND of all the values, I'll take its bitwise AND with v of I, right? So this is the case when I am considering taking the current value. What if I don't want to take the current value? The transition for I will still be the same, and j will be left unchanged, right? So dp of I minus 1 and j. Why? Because I'll still move on to the next element if I don't want to take no take. If I don't want to take the current element, I'll move on to the previous element by doing I minus 1, and since I have not taken the current element, my j value will not change, right? So this was a very straightforward DP problem, and the states were not very difficult to think of, right? So where will be our answer stored, right? This is our next question. So our answer will be stored in dp of n of 63. Now, why am I taking 63 only? Right, this was the important part that I wanted to discuss. So, for example, the first element. So, the first element that you're taking. So, let's say that the first element that you try to take is 3. Right. So, if you're considering to take 3, let's say 3 is represented like this, and 63 is represented like this. Right. So, you will have to take 63. Then only the bitwise AND of these two values will be equal to 3, right? If you do not take it as 63, if you left it as like this, for example, if the next element was this, then still Even if it is 1, the mask will be 0, 0, 0, 1, 1. Whereas the mask should have been 1, 0, 0, 1, 1, because this is the first element that you are taking. So initially you will have to take 63. But the problem with taking 63 as for the answer is that whenever the value of k is 6, right, it will add one more to my answer. Why? Because if I am calculating the answer at dp of n comma 63 and the value of k is 6, then it will also consider the case where I do not take any elements from the array itself, right? I reach here without taking any of those elements, and in that case also my answer will be true, right? It will also count that particular case. So what I essentially have to do is my answer will be stored in dp of n comma 63. I just have to take care whenever k is equals to 6, I just have to subtract 1 from this particular value. Because whenever k is equal to 6, it will also add that particular case into my answer when I do not consider even a single element from the array, right? So this is our second thought. Now the third very important thing is base cases. So what will be the base cases of this particular problem? The base cases will be stored at dp of 0 and some value j. So for all values where number of set bits, so let's say set bits of j is equals to k. So for all values of j where the number of set bits in j is equals to k, dp of 0 j will be equal to 1, denoting that it is a valid path. Otherwise dp of 0 j will be equal to 0, denoting that this is not a valid way, right? So this would be the solution of the last problem of today's Codeforces contest. Now let me just show you the code for this particular problem now. So you see, I've created a dp array I've created a global array, and this is of size 2 into 10 to the power 5. This is 3, 4, 5, yes, and this is of size 65, so that I can take all the values from 0 to 63, right? Now what I do is I'll take two values n and k, and I've created a vector of size n plus 1, right? So now for all the values I just take input in v of I. Now I just run a for loop from 0 to 64. If the number of set bits in I is equals to k, that means I can just set dp of 0i as 1, otherwise I set dp of 0i as 0, right? So this is the base case that I am trying to form, and this particular thing, bit count ll, so this is something I have defined in the top. So this is what I am using, and this is basically used to count the number of set bits in the current number n, right? So what I do is now I just traverse through all the values of I index I, and I traverse through all the values of j of mask. Now I just consider a case where I do not consider the current element, so it will be dp of I minus 1 and j. Otherwise, if I consider the current element, it will be equal to dp of I minus 1 j bitwise n of v of I, right? So I have to consider all the ways, and I have to take the ways from x, and I have also to take the ways from y. So I just add both of these values and take its mod, right? Now my final answer will be stored in dp of n comma 63 and 63, and if k is equal to 6, I just subtract 1 from my answer. So this would be the solution of the last problem, and I can just directly print my answer. So I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video. So like, if you genuinely were able to understand the solution, then please drop a like, because it really helps the YouTube algorithm to understand that this video was actually helpful for the viewers. Now I also see that a lot of people who watch these videos have not subscribed yet. If you are one of them, please do consider subscribing to this channel. It's always free of cost, and you can always unsubscribe if you don't find the videos interesting later. So till the next video drops, keep coding, stay safe, bye bye.